the best solution or the common solution, right? Similar to that कि if you are not able to take the decision कि आपने देखा कि आपके पास 5 sets of mobiles है, आपने approach लगाया, then you कि आप जब analysis किए, then you are not able to take decision, तो आप क्या करेंगे? आप किसी के पास जाके पूछेंगे इसका फीडबैक क्या है, you will take the feedback. 10 लोगों से पूछा, 7 लोगों ने कहा कि ये बेटर है, तो जिसको ज्यादा लोगों ने बेटर बोलेगा उसको आप जाके सेलेक्ट कर लेते हैं. So this similar approach, these methods what we are discussing is we are taking a feedback from the third party by using a scientific method, you can say. So there are these methods are man-made methods. So we can say कि those who have proposed this method, we are going to take a feedback from there. And out of that, if suppose 10 methods are there, 7 methods are saying that number 6 is 6 alternative is the best, then we'll go for 6 alternative. So always keep in your mind when you are writing or when we are writing papers or when we are applying these approaches to any research problem, always try to solve with at least 2 to 3 methods and compare the result. Then only it will give the fruitful output, or you can able to justify. That is why always you will find when you are going for research paper, you are referring any research paper, always you will find they will either use a different method and compare the results, right? Or they integrate with the some other method, right? So that it can be compared properly. So generally आप किसी में देखोगे, आप जहां भी डिसीजन मेकिंग, मल्टी एट्रीब्यूट डिसीजन मेकिंग या मल्टी ऑब्जेक्टिव डिसीजन मेकिंग रहता है, उसमें 2-3 मेथड से कंपैरिजन आपको दिखाएगा. एंड ऑन द बेसिस ऑफ द रिजल्ट दे से कि यस ये तीनों मेथड मुझे ये बेस्ट दे रहा है, और आउट ऑफ 4 में से 3 इसमें बेस्ट दे रहा है, एक जो है सेकंड को दूसरे को बेस्ट दे रहा है, तो 3 विल गो फॉर दिस वन, राइट? So in general, whenever you go for publication, when you are going for any research work, you always try to compare the result with different methods. Don't stick on a particular approach. Am I clear? And this is the objective behind taking so many number of methods and discussing this one individually. Correct? So you may sometimes also find, something that the methods are the same example. The reason behind that why we are taking a similar kind of example is for solving different method, you may get कि कहाँ पे आपका first ranking आता है, and it may be possible most of the cases, if it is always best when we are getting the same answer for all cases, but if there is a variation, we will compare कि हाँ ठीक है 10 में से 6 में सबसे अच्छा आंसर जो आया है, we'll go ahead with that, right? Extending to this conditions, we are going to discuss about the second method, that is desirability function approach. This concept has been introduced by Denninger and Switch in 1980. It is an approach which individual responses are transferred to the corresponding desirability value. Desirability value means desirability value always focused on target value, right? कि आपको क्या चाहिए, कितना चाहिए, right? And suppose I have decided I want a strength of suppose 300 or you want a speed of 300 rpm or you want efficiency of 40%. आपने 40% efficiency fix कर लिया. Suppose कि yes, my target value 40% efficiency should be achieved. My target value strength should be 200 megapascal. I want stress capacity or pressure capacity to be handled. जितना आपका ultimate pressure और stress आप handle कर सकते हैं किसी vessel का, that should be suppose 200 megapascal like that. So अगर आप उस तरह से fix कर लेते हो तो आपका कहलाता है target value, right? Once you have the target value of particular value, then when the value is the best, it will be considered as 1 as condition of maximum, and minimum का condition में देखते हैं तो 0, right? If the variation is between 0 to 1, this is the standard form, right? And if the value is coming 0 in normalized form, in any case, or the target value, suppose you are taking target value of 100, right? If the value is coming 110, then while making a standard table in standardization, when you are doing for the normalization, at that condition, whenever the target value is 100 or the maximum value you are getting, so that value will become 1. And इससे ज़्यादा अगर आपका आता है, so this will be again considered as 1. Okay. Then in the similar case, if we have fixed the minimum value as 50, and if it is going to 45, then it is again considered as minimum है तो 0. So even it is getting 45, it will be considered as 0. So if we are normalizing the table from 0 to 1, and the value within the range what we have fixed, the desirability range of 50 to 100, so if the value is going beyond 100, will also be considered 1. If the value is going beyond minimum, that is 50, then it also be considered as 1. Right? Desirability value depends on the acceptable tolerance range as well as the target of the response. Target value is क्या है आपका target value आप fix कर लो. मुझे ठीक है 50 से 100 के बीच में चाहिए. 50 से 100 का आपका जो target value है, उसके बाद जो value आती है दोनों side, either minimum side or maximum side, that will be considered as minimum side is 0 and the maximum side is 1, even though values whatsoever be the value, right? यूनिटी असाइन एज रिस्पांस रीचेस इट्स टारगेट वैल्यू. आपने 100 आपने टारगेट किया तो इसके लिए 1 आपने असाइन कर दिया, एंड इट इज द मोस्ट डिजायरेबल कंडीशन. बियॉन्ड द एक्सेप्टेबल लिमिट डिजायरेबिलिटी वैल्यू इज अज्यूम्ड टू बी 0. अगर आप एक्सेप्टेबल लिमिट से बाहर जाते हैं तो 0 आता है, राइट? एंड अदर साइड टारगेट वैल्यू से आप स्विच करते हैं तो 0 टू 1 के बीच में जो भी आता है, जो भी उससे ज्यादा होता है या उससे कम होता है, उसके करस्पॉन्डिंग जो वैल्यू है ज्यादा साइड में 1 और मिनिमम साइड जो आपका आता है उस तरफ 0 आ जाएगी. तो desirability function possess one of the following three. The condition is higher is better, lower is better, and third one is the nominal is best or target is best. Higher is better and lower is better, as we have already discussed about that, like the cost. If you are talking about economy, always lower is better condition will be preferable, and higher is better whenever you are talking about the performance parameter, like higher efficiency, higher power output, and so will be considered as the higher is better condition. The third one is the nominal is better. Nominal is better condition is normally used in case of when you are talking about, for an example, the shaft diameter. The shaft diameter, if you are fixing the 10 mm is the shaft diameter, so this is the condition of, this is the target value of 10 mm, and nominal is better, तो इसमें आपका टॉलरेंस लिमिट लग जाता है प्लस और माइनस सपोज 0.5 mm लाइक दिस. सो आप जो टॉलरेंस लिमिट को सॉल्व करते हो इसमें, इस टाइप की कंडीशंस को हम नॉमिनल इज बेस्ट और टारगेट इज बेस्ट कंडीशन जनरली से टारगेट इज बेस्ट और नॉमिनल इज द बेस्ट. So higher is better is simply clear, which we have already discussed. Lower is better is also clear. Now nominal is better means whenever we deal with the tolerance and limit conditions, like in example of the shaft diameter with a particular value of plus or minus 0.5 or 0.05, whatever the tolerance limit we are giving. So these are the condition is nominal is better condition. Higher is better condition, the individual desirability value, you have to calculate the desirability value for that. That individual desirability value can be calculated with given criteria. For an example, now you can see if the value y is the actual value of the decision matrix, right? Value y is less than the y minimum, right? So on the given matrix or that particular column of criteria, suppose you are taking C or suppose B, these are the attributes or criteria, right? And this side is the alternative A1, A2, A3, whatever you are taking, right? So हम एक एक करके एनालिसिस करेंगे. हम इस क्राइटेरिया को पहले एनालिसिस करते हैं. The given criteria and we have assumed the higher is better condition for this, right? And what is the value given here is this one, y. And if this y is less than y minimum, if this y is less than y minimum, देखो यहाँ पे मैक्सिमम ये है जिसको 1 दिया है हमने, एंड मिनिमम ये है जिसको हमने 0 दिया है. And if you draw the graph for this, so this is, if it is less than minimum value, if it is less than minimum value जितना आपने फिक्स किया, तो मिनिमम में तो 0 है ही है, अगर उससे कम होता है वैल्यू, then still it will be 0. So di will be 0 in this case. The desirability value, when the given value of y is less than the y minimum, in the case of higher is better. Second condition, if y minimum is lies between the y minimum and y maximum, y is greater than y minimum and y is less than y maximum, if it is falling on this condition, the value of y, then the desirability value can be calculated by using this equation. This equation says the y minus y minimum divided by y maximum minus y minimum and raised to power r. This r is the constant, and depending upon the value of r, the desirability function curve will vary. Right? Here you can see for higher is better condition, if you calculate the value of di and the value of r is suppose 0.1, then the curve will follow this line. If the value of r is 1, it will follow the straight line as linear curve. Right? If the value is increasing, it will be again following the logarithmic curve. So like this. Right? So these are depends on the value of r, how to draw the desirability curve over here. Finding the value of di. First case, if y is less than y minimum, then di will be 0. Second case, when y is lying between y minimum and y maximum, then di will be calculated from here and it will lies between these values. Normally, if nothing is mentioned over about the value of r, we normally take the value of r is equal to 1. Then if y is greater than y maximum, as I say, the maximum value जो हमने फिक्स किया है उससे अगर बाहर जाती है तो वैल्यू आपका 1 हो जाता है. राइट? अगर मिनिमम से बियॉन्ड जा रही है तो भी वो मिनिमम की इक्वल माना जाएगा एंड इट विल बी rated as 0 or desirability value is 0. If you are going for maximum, if it is going above the maximum value, then still value will be considered as 1. मैक्स जो आपने y का मैक्सिमम टारगेट वैल्यू फिक्स किया है उस पे इक्विवेलेंट अगर आता है तो 1 तो मानते ही है, बट उससे ज्यादा भी होता है तो भी ये 1 के अंदर ही रहेगा. देयर इज नो चेंज ऑन दैट. सो ये टारगेट वैल्यू सपोज 100 से 50 के बीच में है, अगर आपने 100 अचीव किया यहाँ पे तो di is equal to 1. हायर इज बेटर कंडीशन में अगर 110 भी अचीव करते हो तो भी di के वैल्यू 1 होगा. सिमिलरली मिनिमम 50 है आपका, इफ यू आर अचीविंग 45 तो 50 में तो आपने 0 दिया है, एट द सेम टाइम 45 के लिए भी आप di वैल्यू 0 देंगे. एम आई क्लियर?
Yes, sir. Yes, sir.
Fine. So this is higher is better condition. So desirability function for higher is better is done. Okay. Now lower is better condition is just opposite of that. That lower is better means what? Y minimum is desirable, right? So y should be equal to y minimum. This is the target condition. But if the y value is less than the y minimum, suppose desirable condition मैंने मांगा है 50, and minimum is better condition, and condition is lies between 50 to 100, right? So ये desirable condition है, आपका target value क्या है 50, right? And if you are getting 45, then अगर आप 45 आपको मिलता है तो 50 जहां मिल रही है डिजायरेबल कंडीशन है, 100% सेटिस्फैक्शन हुई तो d is equal to 1 होगा. And if further it is going below that 45, then also will have the value di is equal to 1, right? So whenever we are trying to prepare the normalized table, that time the value of di will be 1 when the value of y is less than or equal to y minimum in the case of lower is better, right? So this is di is equal to 1. Then secondly, when the value of y is lies between the value of y minimum and y maximum, In this case, di will be calculated using the equation that y minus y maximum. See the difference. Previous case, y minus y minimum was there. Here, y minus y maximum and then the difference between the maximum and minimum value of y for that particular criteria. Apart from that, there is a power of r. Again, the value of r, depending upon the value of r, the desirability curve will vary in this manner. And if nothing is mentioned, no idea about the r, you can take simply r is equal to 1, which will give the linear curve for the simplicity. Then the third case, when the value is reaches to the maximum value, which is the worst value in case of the higher is better condition, and it will be given as zero desirability value as it is worst value, and at the same time if the value is reaching to 110, 120, then we will take desirability value is equal to 0. So this is all about the higher is lower is better condition. So while normalizing table and finding the desirability value, you will have to use this equation with three conditions. So this is higher is better, this is lower is better. Then the third one is the nominal is better. Nominal is best, or target is best combination. This, as I said, this condition will be applicable and whenever we are dealing with a tolerance conditions, tolerance limit, upper or lower tolerance limit. Like target value is 10 mm of shaft diameter, we are taking plus or minus of 0.05 mm. So minimum and maximum value will be vary between these two. Now the target value is the best or desirable value will be given the value of 1. So ये आपका target value अगर आपने fix किया है तो इसको 1 दे देते हैं, right? And maximum and upper and lower tolerance will be considered as maximum and minimum condition. So wherever maximum is there, so maximum जहां तक जाता है उसको हम यहाँ पे 0 ले लेते हैं, and अगर minimum भी जाता है दोनों साइड में, क्योंकि both the side deviation from the target value both are undesirable situation, right? And if it is reaching to the maximum of these, will be the worst condition for ever, all the cases, either it is lower side or higher side, does not matter. I need 10 mm of diameter of shaft plus or minus 0.05%, plus or minus 0.05 mm, 0.05 mm condition, right? In this case, either it is plus or minus, both the conditions is the worst. So y minimum and y maximum, whatever we are getting, will be always 0 value, right? It is not like that one side is 1, another side is 0. Always, both the case, it will be 0. Now in this condition, when nominal is best criteria is used, so y minimum, if y minimum is lies between y is lies between y minimum and target value, so we are dealing with this phase, this side, right? In this condition, the value of di is given as y minus y minimum divided by the target value minus y minimum. Now what is the maximum value? This is replaced by the maximum value of y is replaced by the target value here. So t minus y minimum will be used here. Now you can say we are dealing with the minimum side, so it will be deal with the y minus y minimum. It is a function of y minimum along with the value of r as a power. Similarly, in just opposite, if the value of y is lies between t and y maximum, which we are talking about this phase, this side, right? Here, the value will be calculated. Desirability value has been calculated by using the y minus y maximum and t minus y maximum raised to power r. Now y maximum and y maximum represented as the minimum or upper or lower tolerance limit for the value of y, and r represent the desirability function index. So this is about the nominal is best or the target is the best combination or condition. Then we will calculate the value of overall desirability. Overall desirability will be given as d0, and this is equal to d1 raised to power w1, where d1 is the desirability value of particular alternative, right? Particular criteria. राइट, पर्टिकुलर क्राइटेरिया एंड पर्टिकुलर अल्टरनेटिव्स। ये हम किसके लिए सॉल्व करते हैं? D0, D0 is for the value of alternative 1, then value of alternative 2. So for first alternative we will find out D1, which is available in the normalized table or desirability table, and the given weightage of that particular criteria W1. Similarly D2 with the given weightage criteria W2, and similarly D3, W3 and so on, and D and Wn is the final value, the last column. This D0 will be calculated for the alternative 1, similarly for alternative 2, alternative 3, alternative 4, like this, and it always lies between 0 to 1. Keep in your mind. Now this D0 is the overall desirability, known as desirability value. Di is the individual desirability value of ith quality characteristics. N is the total number of the responses, and Wi is the weightage of the individual attribute, factor or criteria. Once you find the value of desirability value, then overall desirability, then you can have a ranking of that based on the highest value will be given as the highest rank and lowest value will be given as a lowest rank over here. So what we do here is the steps, if you are talking about the steps over here, the response has to be measured first. Once response has been measured, then we can have the desirability value index. So determination of desirability index for individual alternative and respective criteria. So somehow it is kind of the normalized table which we have used in the previous case, right? And that is why whole data has been converted to the 0 to 1. So somehow this desirability index, finding a desirability index, is as similar to the normalization of table in the previous case. Response measure, what we have written here, is nothing but it is a decision matrix what we have prepared earlier also. So same decision matrix can be used, and you can use for the desirability function calculation over here. Once you have this data of desirability function, then we can have the overall desirability index. You can calculate by using the equation which we have already used, this equation. Then we can go for Taguchi optimization finally. तो ये आप सारे रिस्पॉन्स को यूज करके फिर टागोची ऑप्टिमाइजेशन की तरफ आगे जा सकते हैं। वंस इट इज द बेस्ट कॉम्बिनेशन, आपको बेस्ट अल्टरनेटिव सेलेक्ट करने के बाद आप फिर उसके ऊपर टागोची ऑप्टिमाइजेशन की तरफ आगे बढ़ा सकते हैं इसको, राइट? That is why you always see in your see, if you are trying to write a research paper or work on the any research problem, and you directly apply any single method, generally it is not appreciated by the various journals. Whenever you apply this MADM techniques or MODM technique along with the optimization technique like Taguchi or some other technique, like you will find the gray Taguchi analysis, integration of gray optimization, Taguchi optimization, this type of combination will be more appreciated over here. So first we will use the any MADM technique to make the data for the next optimization, right? Coming to a simple example of decision making problem, the selection of appropriate industrial robot depending upon the following criteria. The criteria are given as what is the load capacity, what is the repeatability, maximum tip speed, memory capacity, and manipulator reaches. These are the 5 criteria has been selected for the industrial robot, and it has been assumed that all the criteria given is beneficial in nature and equally important. Beneficial in nature means what? What is meaning of beneficial in nature? How it will be implemented in our method?
Maximization,
right? So it will be considered as higher is better condition, right? Wherever all the value, all the criteria are considered is higher is better condition, right? And select the most appropriate now select the most appropriate candidate robot utilizing the data given below using the desirability function method. The data are given here. This is the desirability, this is the decision matrix for the selection criteria for the selecting appropriate robot. Let us see, we are having 7 robots over here. So R1 robot R1 having the that load capacity of 60 kg. The value of repetition is 0.5, 0.4. Then the value of MTS is 2540. Manipulation reach is 990. Then one was maximum tip speed, that is 2540. Then what is other is memory capacity is 500. So this is for R1. Similarly, for R2 it is 6.35, 0.15, 16, 3000 and 1041. Now you can see the variation in this side also. If you are talking about the load capacity for individual criteria, this is criteria number 1, 2, 3, 4 and 5 for 7 alternative. So if you analyze the first criteria itself, first criteria is varying from 60 kg to 2.5. So maximum value of this loading capacity is 60 and minimum value is 2.5. Similarly, for other case also you can find out the maximum value here is 0.4 and the minimum value is 0.08. Similarly, here it is 2540 as maximum and minimum is 177. Maximum here is 3000, minimum is 350. Here maximum is 1676 and it is 50 is the minimum value. So you are having all cases maximum and minimum value, but the conditions for individual criteria, desirable condition is what? Higher is better for all cases. So using higher is better for all cases, you can find out the value of DI. This is written as XI here. So you can consider DI here. What is the value of DI? DI for this case? Sorry. Yeah, this equation having a small correction. Please do the needful. Right? I'll just raised to power R is missing over here. Right? So we'll use basically higher is better condition. We'll use these equations. Right? So here we'll use this equation because higher is better condition. So we'll find out the value of DI as equal to Y minus Y minimum raised to power R and Y maximum by Y minimum. So ये equation हमको use करना है यहाँ पे, right? So higher is better condition. We'll use this equation for this case. This is not required. So the DI value will be calculated from here. First thing. Then we are having the some other criteria like minimum and maximum we have fixed. So here what we will do, we will find out the value of you can again repeat the previous equation. Okay, we'll try to find out the value of DI here. So DI for first case, the value of Y is 60, right? Value of Y minimum is 2.5. So 60 minus 2.5, right? So 60 minus 2.5 here and divided by Y maximum 60 minus 60 minus 2.5. So this become 1 here, right? This is the maximum, that is why always become 1. Now you can see it is 1 here, desirable value, right? Now suppose in any case if it is mentioned that we want the maximum, the range of capacity in the range of 60 to instead of 60. If desirability is suppose 55 kilowatt capacity range to 3 kg, इतनी लोडिंग कैपेसिटी के रेंज में आपको करना है एनालिसिस. अगर ऐसी सिचुएशन होती है, इन दैट केस 55 to 60 अगर आता है, तो ये केस में अगर 60 आता है यहाँ पे, तो वो ये वाला इक्वेशन फॉलो नहीं करेगा. आर यू गेटिंग माय पॉइंट? हेलो. If we have constraint, that we can go as a target value of 55 to 3 kg in the range, right? Here, if nothing is mentioned, you can use 60 simply as the maximum. Maximum is better. And r is equal to 1. You will use this equation, always you will get the value of 1. But if the value of y is 60, but the maximum value I have fixed with 55 and minimum value is 3, so आप इस equation को अगर use करते हो तो you will get higher than one value maybe, which is not correct. Here we will not use 1, rather we will not use 1 point something, we will use 1 here, right? So wherever the target value is given, this range अगर 55 दिया है तो 55 में तो 1 लेंगे, 60 में भी 1 लेंगे आप, राइट? मैक्सिमम के ऊपर जब भी आएगी तो 1 होगा और मिनिमम के नीचे जब भी आएगी तो 0 होगा. 3 मिनिमम है तो 3 मिनिमम में तो 1 आना 0 आना चाहिए, बट एट द सेम टाइम 2.5 is also there, so it can be less than 0, but we will not take less than 0, we will take 0 over. In this case we have not made any constraint, but if the constraints are given like this, then you have to select in that way. So now we are applying this one, so you'll find out the value of di for individual case, and we will prepare the normalized table for this condition. So for 60 you will get 1. Similarly for 0.04, so 0.4, so 0.4, and what is the value of y minimum here is 0.08. So 0.4 minus 0.08, maximum value is 0.4 again and y minimum 0.08. So इस condition में भी यहाँ क्या आएगा आपका 1. Then यहाँ 2540 ये भी आपका maximum condition है, अपने आप ये 1 आ जाएगा. यहाँ पे आप 500 लेंगे तो 500 minus 350 divided by 3000 minus 350, you will get certain value over here. So this value will be 0.055566 for this condition. Similarly here, if you are trying to find out with respect to this, the maximum value is this value, minimum value is this. So you can use this 990 minus 508 divided by 1676 minus 508. You will get certain value. This value is 0.412671. This is the value of D5. So D1, D2, D3, D4, D5 will be used for alternative 1. Robot 1 के लिए आपने D1, D2, D3, D4 and D5 निकाला by using that equation as equal to higher is better condition, right? Once you get this value, then you can apply the same thing for R2 respectively there. Then R3 also will get the value of D1, D2, D3, D4. Similarly for R4, R5, R6 and R7. You will again see that each and every criteria, the value of DI, 1 is also present and 0 is also present. All column you can see 0 is there, 1 is there, 1 is there, 0 is there. Means the desirability value is always lies between 0 to 1 in all cases, right? So this 0 to 1 condition, 0 indicate the minimum values and less than minimum value, and 1 indicate the higher value and higher than the maximum value, or desirable value. So this data, once this data is available, then you can find out the overall desirability index. So overall desirability can be calculated by using this method. D0 equal to DI W1, D2, W2, D and W3 like this, D and WN like this. Using this equation, you will find the value of overall desirability as maximum 0.741, then 0.29, 0.26 and 0.33, and these all value are 0. There are possibility in this particular method when you are applying that maybe there are n number of 0 also. Why it is so? Because the overall desirability is a function of product of multiple desirability value. आप प्रोडक्ट कर रहे हो तो जहां भी 0 आएगा वो वैल्यू को पूरा 0 कर देगा, यहाँ प्लस वाला नहीं है, राइट? So that is why there is possibility कि sometime is also possible कि सारे वैल्यू भी 0 हो जाए. Possible हो सकता है कि एक ही वैल्यू आए बाकी सारे वैल्यू 0 हो जाए. So in that case, if 1 is coming fine, you can go ahead. but if all will be become, it's difficult to get the decision over here. And at the same time, if these two values are available and rest of the things are zero, of course you can rank these two, but rest of the robot cannot be ranked. इन दोनों को तो आप कर सकते हैं, बट इन दोनों के रैंकिंग आप नहीं बता सकते. आप बेस्ट तो सेलेक्ट कर सकते हैं इससे, but you cannot rank this. This is the limitation of this desirability function approach in the multi-criteria decision making, multi-attribute decision making. Am I clear?
Yes, sir. Yes, sir.
The important thing is, whenever you are doing the analysis of any method, have you ever tried to see the research paper how it will be used? Have you tried to use this? How you can see whenever you try to use this or refer any paper for either desirability function or maybe for saw method, grade relation or any other method, what difficulty you face anytime? अगर आपको फर्स्ट साइड में एक पेपर दे दिया जाता है, रिसर्च पेपर, दे हैव यूज्ड द डिजायरेबिलिटी फंक्शन, राइट, आपको समझने में क्या डिफिकल्टी आती है?
The selection of R, sir.
Okay, fine. That is okay. That is one selection of R will depends on, okay, थोड़ा tricky है, but generally value of R will be normally in simplicity you can take one, but depending upon the nature of the problem, the R value will be defined by the the whosoever is the involved in that particular problem, right?
Okay, sir.
सेट ऑफ स्टैंडर्ड नहीं है आपके पास कि आर की वैल्यू इस केस में ऐसा आएगा. वो आपका एक्सपीरियंस के बेसिस पे उस आर की वैल्यू को आपको कैसे आपको मूव करता है आपका डेटा, उसके अकॉर्डिंग आपको लेना पड़ेगा, राइट? सो वी डू नॉट हैव दिस, बट एट द सेम टाइम रेंडमली आपको एक पेपर देखिए, इफ यू सी ऑन दिस मेथड, इट्स अ वेरी सिंपल मेथड. जस्ट आपने क्या किया है, एक इक्वेशन यूज किया है, एक पर्टिकुलर इक्वेशन से आपने डीआई निकाला, डीआई करस्पॉन्डिंग आपका स्टैंडर्ड डेटा आ गया, उस स्टैंडर्ड डेटा को यूज करके आपने फाइनली ओवरऑल इंडेक्स निकाला. ओवरऑल इंडेक्स में आपने देखा कि जो हाईएस्ट वैल्यू ऑफ D0 आ रहा है, दैट इज रैंक्ड एज 1 एंड द बेस्ट क्राइटेरिया, बेस्ट अल्टरनेटिव, राइट? बट when I will give the similar paper to you which is published, you will be confused. Reason behind this is, आपके दिमाग में अगर ये पता है आपको कि ये मेथड कैसे काम करता है, then you can work it, you can find out. But राइटिंग स्टाइल को इतना कॉम्प्लिकेटेड करके लिखा जाता है. Have you observed this? जो आपके पेपर्स होते हैं, I was just trying to find out some paper over here, इतने कॉम्प्लिकेटेड वे में आपको राइटिंग लिखी जाती है कि आप पहले देख के घबरा जाओगे. यस और नो?
Yes, sir. The equations written sigma y all that.
में आपको ये कर दिया जाता है कि आप पहले तो उसको लेके आप घबरा जाओगे कि क्या लिख दिया पता नहीं, राइट? सो वहां जाके आपको घबराना नहीं है. मैं आपको एक एग्जांपल जस्ट फॉर सेक ऑफ अंडरस्टैंडिंग आई विल शो यू. नाउ यू कैन सी दिस इज रिलेटेड टू डिजायरेबिलिटी अप्रोच. इतनी कॉम्प्लिकेटेड इक्वेशन लिख देते हैं, और देखो आपको अगर मैं आपको एक टिप्स बोल रहा हूँ, whenever you are trying to solve the problem or crack the paper using the method which you know or which you have already studied or understood, what you should do first is go for reverse engineering. Are you getting my point? Reverse in the sense what? इनपुट से आउटपुट की तरफ मत जाओ, आउटपुट से इनपुट की तरफ जाओ. Are you getting my point? आप टेबल से चालू करो सॉल्व करना, वापस जाके यहाँ कहीं पे आपका दिया होगा, I was just looking for this one, the value of D0, D mu and all, right? इसमें आपका 10 में जो कन्वर्जन किया है, they are given the weightage, the value of x1 u is there. No, this not this paper. So कोई भी पेपर आप उठाओगे, this is something different I was looking for. So आप अगर इसके पेपर उठाते हो, राइट, तो इसकी डिजायरेबिलिटी वैल्यू इन्होंने निकाला हुआ है, D0 एंड ऑल, राइट? सो उस डिजायरेबिलिटी वैल्यू से पिक करना चालू करो आप. आर यू गेटिंग माय पॉइंट? हेलो? इसमें दो मेथड,
यस
आप वहां से करना चालू करो और वहां से रिवर्स जाओ, right? Then you will be easily able to understand the equation what was written and how it is applied. And rather आप ये भी कर सकते हैं, कोई भी पेपर में आप टारगेट करो किसको, जो आपका डिसीजन मैट्रिक्स होता है, डिसीजन मैट्रिक्स उठाओ, मेथड आपको पता है, आप सॉल्व करो, मैच करो फाइनल आंसर से, राइट? देन यू विल बी एबल टू अंडरस्टैंड कि हाँ यहाँ ऐसे किया गया है। उसके बाद फिर इक्वेशन में जाओ, आप इक्वेशन को अपने टर्म्स में लिखो, यू विल बी इजीली हैंडल दिस वन, दिस टाइप ऑफ पेपर, राइट? सेकेंडली समटाइम ये होता है कि दो दो मेथड को क्लब करते हैं, इंटीग्रेशन ऑफ टू मेथड्स। जब ऐसी कंडीशन होती है तो जनरली ऐसा होता है कि ग्रे के साथ, ग्रे या टॉपसिस मेथड या कुछ ऐसे मेथड है जिसके साथ वो क्या करते हैं, डीओई को लगा लेते हैं। तो पहले आप डीओई को समझ लो जो आप समझ चुके हो, फिर ग्रे के साथ अगर डीओई लगाया है या आपका टॉपसिस के साथ लगाया है, सा के साथ लगाया है, जो भी मेथड के साथ लगाया है, आप उसको फिर से रिवर्स जाओगे तो आपको समझ आ जाएगा कि पहले उसने क्या किया, ग्रे लगाया, ग्रे के ऊपर से जो आउटपुट आया उसको फिर उसने डीओई में लगाया एंड देन इट हैज बीन यूज्ड फॉर दैट पर्टिकुलर प्रॉब्लम। तो दो तीन प्रॉब्लम आप पेपर उठा लो, पेपर को क्रैक करना चालू करो, देन आपको सबसे बेस्ट तरीके से यू कैन able to apply these methods what we are discussing here. Okay, gray relation से related I have one paper, so I will discuss how to club this with the design of experiment in Daguchi, so that I will discuss. So similar उसी method को आप उठा के आप solve कर सकते हैं किसी और